The gigantic void. What the James Webb Telescope just revealed could change everything. Asterisk, there is something out there in the cosmos that should not exist. It stretches across millions of light years. It defies our most sacred theories. And it may, just may, be the key to unlocking the greatest mystery in the universe. Asterisk. Hashtag part I. A universe in crisis. For decades, cosmologists believed they were zeroing in on a complete understanding of our universe. From the elegant symmetry of Einstein's general relativity to the stunning discoveries of the Hubble Space Telescope, it all pointed to a cosmos that was smooth, predictable, and expanding at a measurable rate. But now, thanks to the most powerful telescope ever launched, we are watching those assumptions fall apart, piece by piece. The James Webb Space Telescope, JWST, humanity's eye into the ancient cosmos, has found compelling new evidence that the long-debated Hubble tension is real. And that changes everything. At its core, the Hubble tension is a conflict, a war between two numbers. One number, derived from nearby galaxies using standard candles like Cepheid variables and Type Ia supernovae, tells us how fast the universe is expanding today. The other number, calculated from the cosmic microwave background radiation, the afterglow of the Big Bang, tells us how fast the universe should be expanding based on its early conditions. The two numbers don't agree. Not even close. And that shouldn't be possible. But now JWST has made things worse, and much more interesting. Hashtag part 2. The rise of the voids. Recent JWST observations have revealed enormous voids, regions of space so vast and empty they seem to swallow the light itself. These aren't minor gaps in the cosmic fabric. They are vast, gaping abysses, some stretching over 100 million light-years across. Within these voids, where thousands of galaxies should be, there is nothing. No stars. No clusters. No galaxies. Let that sink in. Light, the fastest thing in the universe, would take over 100 million years to cross one of these voids. In that time, entire species on Earth could rise and fall, yet the photon would still be in the abyss. And according to Einstein's equations and the lambda cold dark matter lambda CDM model, our standard model of cosmology, such voids should not exist. Yet they do. Hashtag part 3. A broken universe? Our universe is supposed to be homogeneous and isotropic, meaning it looks the same in all directions, no matter where you are. This assumption underpins almost every major cosmological theory, from the Big Bang to dark energy. If the universe isn't homogeneous, if massive irregularities like these voids are common, it means our theories are built on a foundation of sand. And it's not just the voids. JWST has revealed galaxies so old, so mature, and so well-formed that they shouldn't exist at their observed distances. According to the timeline of the Big Bang, there simply hasn't been enough time for these galaxies to grow that large, become that complex, or form such massive black holes at their centers. In other words, the early universe looks far too evolved. Hashtag part 4. The filaments and the web. Zoom out far enough, and you'll see that the universe forms a vast cosmic web, an interconnected lattice of filaments composed of dark matter and gas, along which galaxies and clusters migrate like cosmic trains on invisible rails. At the intersections of these filaments lie enormous nodes of matter, galaxy superclusters, star nurseries, and even gravitational wells so deep they bend light itself. Between the filaments, the voids. They're not just empty space. They are the absence of space, like pockets carved out of the universe itself. How could such enormous bubbles form in a universe that's supposed to be smooth and uniform? The terrifying answer, we don't know. Hashtag part V. Pandora's cluster and the forbidden giants. Among JWST's most shocking discoveries is the Pandora cluster, behind which lurks a colossal structure, an aggregation of galaxies so massive and so close to the Big Bang that it should be impossible. This structure violates the laws of standard cosmology in the same way the voids do. If the early universe was homogeneous, then there simply wasn't enough time, matter, or gravitational influence to create something this enormous. And it doesn't stop there. In 2015, Astronomers discovered a group of over 70 quasars spread across 4 billion light-years, a structure that should not exist in an isotropic universe. Quasars are the ultra-bright, supermassive black hole-powered cores of early galaxies. The fact that they cluster at this scale is like finding a continent-sized city of lighthouses in a supposedly empty ocean. Hashtag Part 6. Time, Light, and the Broken Ruler. Measuring the universe is hard. Really hard. We can't stretch a measuring tape across galaxies, so we use light, its speed, its behavior, and its interaction with matter. Tools like standard candles help us determine distances, but even these fall apart when faced with the Hubble tension. It's like measuring your living room with a ruler one day and a laser the next, and getting two wildly different results, except your living room is 13.8 billion light-years wide, and you're trying to measure the fabric of time itself. We are now forced to confront a radical possibility. Either our measurements are wrong, or the universe itself is far stranger than we ever imagined. Hashtag Part 7. The Multiverse, Alien Engineers, and Cosmic Collisions. What if voids aren't just empty? Some physicists propose that voids may be relics of collisions between universes, scars left behind when our cosmos bumped into another in the early moments of the multiverse. In this view, our universe is just one bubble in a frothing cosmic sea of realities. Where they collide, strange things happen, like massive voids, impossible structures, or distortions in physical laws. Other theorists, inspired by Kardashev's scale of supercivilizations, imagine even wilder scenarios. What if voids are the work of advanced alien engineers, beings who can darken entire galaxies to harvest their energy? What if voids are the remnants of galactic Dyson spheres, operating at a scale so vast we can't even comprehend the mechanism? It sounds like science fiction, but it's all rooted in physics. And what's more terrifying, that these theories are wrong, or that they might be right. Hashtag Part 8. A new cosmology dawns. It is becoming increasingly clear that our universe is not what we thought. The James Webb Space Telescope, like a divine eye peering through time, has cracked open the firmament and revealed something chaotic, beautiful, and utterly confounding. Our foundational ideas about a linear, homogeneous, expanding universe are no longer safe. We may be standing at the beginning of a new cosmological revolution, one as profound as the shift from a geocentric Earth to a heliocentric solar system. So what's next? Are we moving toward a universe with no beginning and no end? A multiverse bubbling with possibilities? A cosmos shaped not by elegant equations, but by incomprehensible forces we've only begun to sense? Hashtag Conclusion. Scratching the surface of infinity. We are no longer certain about the age of the universe, its shape, or even its basic composition. Our understanding of light, time, and matter may only represent a fraction of reality. We may be peering into dimensions beyond our grasp, seeing only the shadows cast by higher truths. Voids are not just absences. They are signals, cracks in the mask, warnings or invitations depending on how we choose to see them. One thing is clear, the universe is not done surprising us. So stay curious, stay open, because the next revelation might change everything. Subscribe to the channel and prepare for more stories from the edges of space, time, and imagination. Because what lies out there is stranger than fiction, and it's just getting started.